All right. Hello, everyone, and welcome. Great to have you all here today. My name is Matt Forrest, and today we'll be talking about how to use generative AI within the context of geospatial analytics. So I've kind of been tracking this, as have we at CARTO, for some time. I think there's some developments that you are all probably aware of that we'll talk through, and then some that are really taking place in the current moment, and changing quite rapidly. So I think this is a cool space to explore what's practical here. I think a lot of the reading has been very theory based so far in terms of what we think we can do or what we think we might be able to do at some time. So I'm excited to kind of share what's really going on. So with that, I'll wait a few minutes just to let everyone in. We'll get started here, let's say in 2 minutes. So we'll go from there. All right, so I'm going to go ahead and share these slides here. Um, and I think if you hadn't joined already, there's nothing new here that you haven't seen as of yet. But my name is Matt Forrest. Like I said, I head up sort of our field CTO operations here at CARTO. And today we're talking about, kind of course, one of the hot topics within, I think, just about everything today, which is, of course, all things AI, but specifically looking at generative AI that can build and create things like text or images, and how does that actually get used for things within geospatial. So that's what we're really going to be focusing on today. This is a picture of me, but I think that kind of is self-explanatory at this point. And yeah, so let's go ahead and get started. Just some housekeeping items. If you have a question anytime, there should be a chat that you can kind of drop some questions into. So we'll be periodically reviewing those and checking those out. And then apart from that, we'll definitely share some time for more open questions at the end, should you have them. But before that, just once again, thank you for being here, taking the time out of your day to check this out. We're excited to dive more into this issue. So as we started, I think there's, 5 components that I think you can actually use generative AI for right now. Looking at the whole AI space, there's a lot of things happening. And we're very focused on generative, which could be image or text-based, and text-based being large language models, or, the images being anything from, making up imagery, or those kind of taking your photo and making a cool looking avatar. So it's really a wide space right now in terms of what is doable, and what is happening. So it's a very, just to start with, if you're feeling kind of like there's too much to understand, that's probably because there is. So we're going to focus on what you can actually use with geospatial analytics really today, and this is a ever moving target. I found things in this presentation as early as this week. There's constantly things evolving and happening. So it's near impossible to stay on top of this as much as we can, but that's the goal, is to kind of give you a sense of what this looks like from things we're seeing, things we're doing, and what the broader space within geospatial is as well. So given the full scope of everything that I've seen it used for, there's really 5 levels to this that you can really use geospatial and generative AI together. They're kind of step by step. You can certainly skip others, but I think this is a foundational framework for building upon, starting at the top here and then moving down to the bottom. It's also, I think, framed into have the least risk within each step, and each step adds progressive levels of, I don't want to say risk, but things that could be inaccurate, right? These models are not perfect. These models are not people. The code they write won't be perfect. I've had ChatGPT lie to me about things. So there is a certain level of what do you want to say, risk, and sometimes even what they call hallucinations within these models, where they'll just make something up, right? So you have to be aware of that, is that they're not perfect. And I think assuming that they are is a very dangerous space to begin with, but they are very good, and a lot of them are very good for what they do. So but we're very in a sort of like an early phase of some of these things have been around for some time, but we're really seeing how it's used once it's released to, well, just about everybody that can use it. So the 5 steps we'll talk about today are first around code generation, right? And this being sort of like the lowest risk and easiest to adopt. Basically writing code to assist with human-driven processes, right? This allows you to understand or look up or do things faster in your current job. And it could be more than code. It could be steps to perform an operation or anything like that. And that's what you can do there. The second is feature labeling. So actually designing prompts to a large language model to generate human readable labels about your geospatial data. That can make them much easier to understand by just about anyone looking at them, instead of just numbers or things like that, to increase sort of, how well they could be understood by an audience that maybe hasn't worked with the data or hasn't, interacted with a map or a geospatial kind of dashboard before. The next is sort of retrieving data. So actually using a text input to get data and put it back on the map, or understand or look for data sets is a very common one there. And I think that's a very interesting case that we've been exploring quite a bit, but actually using the text to sort of, find the data, not necessarily interact with the map, but find the data. The next step is sort of what I described, which is the interactivity with the map. So you actually want to use a text input to manipulate, your application or your data to do something, right? That's kind of the next step, is actually interacting with that. And I think there's, certainly, a lot of parallels to that with, popular apps that, if you're in or make a map or tell people you make maps, everyone assumes you work with Google Maps. There's a lot of parallels there to how people interact with probably what's the most common mapping application on the earth. And then the last one is building custom models. And this is the earliest one. I've only found 2 so far that really are true generative AI models that are specifically focused on geospatial, whereas there's hundreds, if not thousands, focused on many other specific topics, and then, lots and lots of generalized ones. So there's a lot here to kind of explore and dive in. So let's get started. This is just kind of a contextual to look at how large language models specifically have sort of started to evolve, right? And you can kind of see where these have grown over time. They've certainly been building since 2018. If you look at this over here, you can see that GPT in version 1 and 2 and then 3 have been growing since in 2018, 2019, and 2020. So it's not like this is the first thing that's ever come out, right? ChatGPT is only recently branched off from GPT-3, but certainly more and more, and you can see the recency and how much it's expanding, within the current day. So there's just a lot that's moving and growing and changing as much as, within the current state. So this is moving fast, right? And I think anyone can kind of understand that. And we're just starting to kind of see how this bleeds into geospatial. But I think just to give context, this is still pretty new, even though people have been working on these problems for a long time, it's just hitting kind of the broader market now. So the first and most obvious way to kind of begin is improving, your code and writing it faster, right? This is a process that you might be doing on a pretty regular basis, something that you want to work on quite a lot during your day-to-day. So, just to keep in mind that, that's something that might be happening all the time. So that's our first step we're going to kind of start to take a look at and use, right? So what does that sort of look like? Let me click over here. This is already available in a lot of, kind of common tools, right? This is sort of from, an example within BigQuery, where they actually can, generate text, from a model and write this within the code you're writing, or actually generate code from a text-based input, right? So you can kind of tell the query that you want. And of course, this has been done many times. We can just do this right now. Write a PostGIS query to find the spatial intersection and aggregation of points and polygon data set. And we'll see what it comes back with. Now, why is this able to do this? There we go. So why is this able to do this? Well, these models, these generalized models, GPT 3.5, 4, and many others, are just trained on a massive, what you call corpus of data, right? Basically anything that's on the internet. And of course, that PostGIS documentation, your desktop tools at QGIS, your Python documentation is all on the web. So in effect, it's been trained on that plus everything relating to SQL, right? So you just have this massive body of information that it can pull from, which allows you to do things like this. You can see we can select here, you might not necessarily need this ST union, but you get these errors, right, that are not totally perfect. You can do the from, the join, on, and then grouping by, right? So you can certainly do all of that. It says it wants to join them into a single polygon, but technically not necessary. But this is an easy thing to do, right? You can also use it as sort of a reference for documentation. If you have some code, right, and you want to get it checked or see what's going on, you can certainly do that as well. So you could, share a code snippet, see if it works, or do anything of the sort from that perspective. So it's easy to do this, right? And the risk is what I would say low, because you're writing code, you can easily copy it, amend it, and see if it works, see if it fails. You're not in sort of like a massive risk from that perspective. So it's something that you can do. There's a few videos I've put out about this, and this is one here. Just want to make sure it's on mute. But if you want to check this out, once I get past the ad, there's a few different use cases here. And now there's another ad, of course. Sorry, guys. But once you can kind of see this, there's different things. You can get it to write some prompts to turn a shapefile into GeoJSON. So we're just tells you exactly what the code is, how to use it, so on and so forth. And you can get more and more advanced, right? I think there's some different ones to do, like a rasterio based vegetation model, and you can see what that comes back with. Now, like I said, it's not perfect, but at least you have somebody looking at this and reviewing it. So there's a lot of ways to do that. I think that's a very simple one to do. Let's keep going here. So those are some of those examples. I should have afforded to that slide first of all, but that's kind of what you can see. And there's a few, like I said, writing code, getting it checked, basically using it almost as a documentation for what you're doing, right? It's easy to reference documentation, see what's going on, and do it in a very human readable way, rather than filtering through massive amounts of Stack Overflow questions to get it figured out. This is a good place to start to speed things up. So very simple one. I don't think there needs to be any more explanation on that. But that's something that I think is very easy to do. Our second use case that we discussed was labeling, right? Imagine you have a semi-complex data set. This is an example that we've been using to label 5,000 different buildings. This is based on sort of analysis of where to prioritize planting trees in Madrid to reduce sort of urban heat islands, right? And looking at a number of factors, including population and demographics, as well as, some of the environmental factors around that area. Where should the city prioritize planting trees? Now, you can show a map like this that tells you, okay, I can see where these buildings are, right? Dark red, that makes sense. But why, right? There's a lot of underlying data, potentially tens of, if not hundreds of features you could use to actually analyze something like this. So how do you make that really easy to understand for someone who's maybe not spending their day-to-day doing geospatial analysis or interacting with this? And that's another very good use case for, generative AI, large language models. They're the thing they're best at is taking text and returning something back, right? You give them sort of input and it puts it in a text-based format, which is right an example you can see here. So the planting priority is very high. It's a densely populated urban area, notable to youth and senior citizens. It lacks green spaces, has high building counts, increased land surface temperature, and nitrogen dioxide levels. Yet it has a high tree planting priority score due to its exposure score. Now, anyone making decisions could see why that is and also compare. I mean, if you're imagining filtering a map and you have all these dark red areas, now I can actually go in and see why that is instead of spending hours trying to figure out how to filter a map. And I think that's the end of the day as a dashboard or, an analyst. That's your end goal, is to really get it, into make it useful for, somebody else to do something with. So what does that look like? This sort of speaks into the concept of prompt engineering. If you're not familiar with prompt engineering, this is basically structuring the input of your data to get a very specific response back. And there's a few different, ways to do this, but you can be as specific as you want. You can give it, this is a very specific version here, given a set of parameters for a particular location within the city in the format of, in this sort of data array, temperature, nitrogen dioxide concentration, population, vegetation, the distance to park, give it values from 0 to 1. And these are the weights for these different parameters. So you can actually give these weights here. Please calculate the score index and provide a brief description of the location. So it actually goes to the score, but it also tells you why, and then you can weight them, which I think is just, this, if you just show this as raw data, someone may or may not get it. This makes it very easy for anyone to understand that problem. I think that's the end goal of, not just people doing spatial analysis, but geographers, is to make it very understandable for things to happen. And that's the end goal here. So this is a very cool one. And it's, once again, it's very, I would say, low risk, because you're structuring the prompt in a very clear way. If you're giving the model enough to work off of and enough parameters to stay within, it's a pretty easy way to get that going and actually do that correctly. So that's, once again, lower risk, but you are potentially opening this up to some text written here that may not make sense, might be wrong, might not be what you want. So be aware of that. It's worth review, but once again, lower on the risk scale from there. This is sort of, another way to do that. You could be more specific. It boasts excellent air quality, high house prices, but it has limited amenities, poor school quality, things like that. Now, this is, more of a real estate kind of use case, but once again, going back to here, having a correct prompt is probably one of the most critical pieces. And definitely, as you are doing what would be called prompt engineering, play around with that. You can even give it a structure of tone or voice or authority or anything like that. I mean, you can get very specific in terms of how you want to write it. Imagine you are a data analyst, imagine you are a government official, whatever that is. You can really give it a clear direction in terms of what you want written. So don't shy away from, structuring in a way that you feel is appropriate for your needs. This is something we've been playing around with our workflows tool. So, we've had, these experimental generative AI components from OpenAI and the Google Bard model, or Palm 2 models, I should say, that allow you to actually create this from a workflows perspective. So what you can do is you can take this data and create a composite score with your weights, just like we did. So you're basically taking multiple values and returning a score of 0 to 1. You bring it into the buildings, and then effectively you're adding it into that LLM model, and then you can create alerts from there. So it's very easy to kind of structure that using these models to actually spit out text like you can see here below. So, you can give it a very clear prompt on how you want it to do that. Another one that's sort of for labeling, it's not just for your vector data, right? Labeling, of course, you want to label features from potentially raster or satellite imagery. This is an example from, it's the segment geospatial package in Python, and it uses under the hood the segment anything model. I believe that was built by Meta or Facebook, whichever you want to call it, and effectively allows you to, look at images and the core of it is like, look at this image and tell me what is a dog, like show me what's a dog in this image, or show me what's an apple, or find the color red, anything like that. You're using that same concept, but for labeling of features from a satellite here. And what I'm doing here is, looking for cars in a parking lot, right? And there's adjustments, there's weights, there's all these things you have to play with. It's not perfect. This imagery is just from Google, Google Satellite, so it's not totally perfect. It's just some of the free imagery. If you had more accurate imagery, I'm sure the results would be much better. But there's a lot you can play with, and you can do this today. The package is open, segment geospatial, and you can take a look at that and run some sample notebooks. It's another wonderful package from Dr. Qisheng Wu from the University of Tennessee. And I think it's just another amazing way to do that. You could label water, you could label whatever you want. We'll get to another example of this later. at the end of how we've seen this applied for very specific geospatial use cases. But once again, not perfect. It thought this little green space here was a car. And you can obviously see I'm missing some here due to probably a combination of the input weights or things like that, as well as the granularity of the imagery. So just something to keep in mind. These aren't perfect yet. We're not, we're still getting there. But the fact that I'm able to do this in a few lines or a few cells with Jupyter Notebook, compared to what it would take to run this on maybe like a TensorFlow or one of those, a PySpark or whatever you want model, this is pretty good to see this go from this, from that direction. Okay, so moving to the third section, using text to get our data for us. Now, of course, if you're writing against data or trying to find data, sometimes that can be very complex. And OpenStreetMap actually provides a very good frame to look at this through. OpenStreetMap data, of course, has a massive amount of data, but there's a lot tied to it. Of course, you have nodes and ways and different sort of what you would recognize as geometries or points, lines, or polygons. Sometimes you have tags that are nested. The tags may or may not be consistent. You have different relations between tags, just for the road types. I was importing some data for just specific roads, and the sheer number of, categories that could be a bike path or could be a road are pretty extensive. And of course, that varies from country to country or place to place, and the accuracy, and are these things tagged or not. It's a very good data set, but from a querying, if you're used to querying as a pure table from columns, getting this nested data can be very difficult. And ultimately, this is kind of what some of the SQL might look like. And you could generate this from ChatGPT and show what that looks like. You can just see here, this is a little bit more than your normal SQL query, where you're nesting and unnesting values and keys and intersections and all of these things, right? There's a certain level of complexity to this. If you work with this data on a regular basis, you could definitely understand that. And there's lots of tools to do this outside of SQL. Of course, you could do this with different packages and the Overpass API and things like that. But it's still complicated. Just having a mental model of what this data looks like is very difficult. So our goal is to say, like, what could you actually do this question and get me all of the things that are healthcare facilities in the south of Spain, right? And this is just written into SQL. We're just passing this text into a model that lives within, in this case, BigQuery, but it could be any tool that supports this. And lots of tools are really starting to support this. From most of the data warehouses have some component of LLMs built into them, BigQuery and Snowflake and Redshift. And you can also see these from other tools. DuckDB, the serverless version of that called MotherDuck, has the ability to pass in a text and get a query back, or write a query from text or anything like that. So there's lots of different ways that this is already starting to show up in tools in the wild that are sort of supported in the production version. So you can actually do this from here to say, give me all the healthcare facilities in the south of Spain. This is just a function that we created, and it does it, right? You can see here's all my points, right? And that's just one example of this, right? There's another video I put together over here. Just make sure it's on mute. This is looking at some, the ability of using LangChain, which is basically a Python wrapper around some of the common models. In this case, I'm using the GPT model. So this is, I started with doing NBA tracking data. I like basketball, so just want to play with that. But you can certainly do it with, spatial data as well. So I guess they have to run another ad. Sorry about that. Thought I preloaded these, but I guess not. So what we're doing here is writing a spatial query, right? We're going to actually ask a question of, let's go over here. And I think we actually write the text out here. So we're going to use this template, your SQL analyst that's querying a database that contains two tables. One is 311 calls in New York City and New York City neighborhoods. Your job is to write a query that executes the following, right? And then you build this prompt and you put the query here, which in this case is how many 311 calls took place in Stuyvesant town, right? A very simple text-based answer, that I'm trying to provide and get a spatial question back. And what's cool is, it actually will go through this and write this query here. You can see select count from the tables, the intersection, and it does it. And it actually spits it out as free-based text. There's 1,699 311 calls in Stuyvesant town. And you can check this out later. excuse me, I do a little bit more, kind of complex querying and things like that. It's not perfect, but it does it. And it actually is generating your SQL for you or pulling data for you. So those are two different use cases. I think a third within that is actually doing like data discovery. This is another example I found online, and people can actually interact with maps like this. So there's a post, and I'll try to summarize these links for everyone as well, using ChatGPT and GIS. This is from Forrest who put this out. And basically, there's this text entry here to say, within a bounding box, find fire departments, which is here. It's basically a text-based input. What are the ski accidents per state? And you can see which states have more or fewer ski accidents or shark attacks or whatever. You're just entering a basic text input and getting a map back, right? And once again, I can't emphasize this enough, is getting the correct, prompt, right? Having clear prompts and what that looks like is super important, right? So if you can do that correctly, and structure the data in the way you want it back, you're going to be probably pretty successful doing this. So I can't like overemphasize that, it kind of shows up in the video as well, but that's a very key thing to be aware of. So this is another cool example. Thank you to Forrest for putting that together. No relation, but and then I think it also can clean up the other problem, which is finding data sets. There's a lot of time I'm sure you spend searching for data. These large language models are just trained on a corpus of data, right? If we can train even a model or just use that to search for data sets that would be relevant for climate or wildfire, or what data falls in California, and just ask that as a very, text-based question, I think that's another great use case for this. And this is something we've been playing around with. You've probably seen AI tools pop up in documentation tools, if you use like Gitbook or anything like that, where you can just ask a test-based question and scan all the documentation in one shot. This is kind of the same thing as you're scanning, tens of thousands of data sets. Now, imagine if this were done for the entire internet, how interesting that might be. So it's not there yet, but it could be. There's no limit on kind of what these things can do. So this is kind of an experimentation. Once again, very clear prompt here. You're an expert on location data. What would you recommend to use detecting wildfires in California? And here I can kind of tell you some basic things coming back from that, which you might want to use. And then actually, if you can connect that to a model like this, here's what you actually can use today based on what you have access to or what's available on the internet. And I think there's also another way to do this. We're playing around with this with the data observatory. This is a general answer from ChatGPT to say what's there. And then actually, here's the real data that you have that you can actually use to do this, which I think is very cool for us to see what we were able to do there. So kind of your general model here, which is just the GPT 3.5 model, which is trained on the internet. So it can tell you general things you might want to care about. And then that model plus what we have in our data observatory. So we're giving it more data to study and then returning that back, which I think is just another cool way to use this. All right, so this is kind of the fourth level, the 5-level ring. And this is actually, using generative AI to interact with maps or dashboards or what have you. It could be anything under the geospatial kind of umbrella, right? This, I think, is potentially really interesting because it can really change the way that we interact with dashboards or maps. I think a lot of us think through the process of either clicking buttons or writing queries or filtering widgets or what have you in terms of creating an application that people can use. What that assumes, and I think something that's important to think about, is that everyone knows how to do that, right? They have some level of understanding of how to, if they see a filter toggle over here, to do that. Not only what it does, but what's it going to impact on the map? How does it impact my analysis? And for me included, I can figure that out pretty quickly. I've been through enough of these things where I can see what I want to get to and looking for. Not all, teams or individuals or citizens might be able to do that. And I think that's a really important thing to think about. The level that, it's these tools have enabled self-discovery is very good. But I do not think that, kind of from our space broadly, we've always held up the bargain of showing you how to use them or providing that education, which I think is important as well. What this allows us to do, and is basically put that in a very text-based model, right? I think that, if you think of AI as a new user interface, it's a very simple saying, but this allows people to actually use that from an AI perspective. And I just want to highlight this is because I think people are actually pretty familiar with interacting with maps like this. If you open up Google Maps, you're thinking in text, find restaurants near me, find the nearest bus stop to, my hotel in San Francisco. You can think through these things contextually, spatially in your mind, and this is for stuff that exists in the real world, whether it be, like I said, food, transportation, entertainment, whatever, right? You can basically think of it from that perspective. But now, can we use that to think through spatial analysis? And I think that's a very, very interesting question to answer. Think about is, if we can assume people generally know what they want to see, what are areas are most risk prone to, urban heat islands in Madrid, they can effectively put that question in. And now we can actually use the model to put that data out. So we're using the text, kind of like what you saw in the last video I showed, to generate a query filter map, do something ultimately to get that out there. Now, this represents probably the higher level of risk because has a few layers here, and it assumes that the person inputting that data knows what they want, or what they want to get out of it. It also assumes that that text is interpreted properly to the context of the data on the dashboard or the map that you're showing, right? So it has to not only understand that data very clearly, what it does, how it interacts, all these different factors about what's happening there, and then be able to render that backwards, to basically filter the results or show it or change the styles or whatever it might be doing. There's a few levels of understanding that need to be completed, which has always had some difficulties. So this is sort of a example of this. Show me all the Starbucks in California. Very simple, hit a search, and then you get data back, right? It's kind of similar to what we did before, but it's easy enough as that it understands that these things are called Starbucks. Okay, now a little bit more complicated. Who are its competitors? Okay, well, what logically would be a competitor? Could it be a restaurant, a coffee shop? And it went with coffee shops, right? So you can see how you can stack these questions, stack discovery in a very logical sequence here that people can use. And I think this is very, very cool because it's the same, this search bar is no different from the one with Google Maps here. You're typing a question, you're typing a question here. We're just applying it to an analytical dashboard. And this is probably one of the more interesting cases for me right now because it just opens up all this work from a geospatial perspective that we're doing to a lot more people. And I think that's very, very promising, if I have to say, if nothing else. So what does this look like in reality? There's a few other cases you can use here. So this is a tool I've came across. I think it's in waitlist mode right now, called Carbon GPT. So if you know anything about carbon sequestration or the rules and regulations around that, it varies from state to state. Regulations can be buried in documents or PDFs or anything, right? And there's all these geospatial factors by county, location, proximity, right? All these things you have to consider as spatial questions that make it very complex. You're not only scanning through pages and pages of regulation and rules and then trying to figure out how to apply those, but also trying to figure out where to apply those in a spatial context. So this, I think there's a short video on their website. If we go to Carbon GPT, and it's really a dashboard. At least as of today, I didn't see a map component here. But what you can do is you can log in, you can get your basics, kind of write a text-based question, see where there's these carbon, kind of understanding your carbon footprint or whatever that looks like. And you have this text-based feature here to actually type this in and get these results back, right? Now, imagine you're bringing this into other planning scenarios, as you can see here, or forecasting, whatever that is. You can ask basic questions from text and connect it to all these disparate data sets, your spatial data, your non-spatial data, that's text. This becomes very interesting for me, is actually doing some things like this, so it actually can do all of these different pieces. So this is just one sort of early example of that I've sort of seen. There's really only a few that can kind of bring that, but I think this is like, we're going to start seeing more of this. There's a few people getting there, but more and more things like this where you can type a question, get an answer, interact with the map that way. That's kind of this next highest level. But I still think, like I said, some of the risks there need to get figured out, and it might need to be contextualized every time, because once again, these models, the most common ones, if we'll just go with GPT-4 or Palm or some of the big ones that are basically trained on everything, the internet, as it were, they're general. They cover every single piece of text that's out there. There's not ones that say, here's the relationships between spatial data, at least as it's specific to your use case. They're I think that's where that might need to go, but we'll see. So it's kind of, this is, like I said, very emerging, but a trend I'm seeing, at least initially. So where is everything going, right? And this is my fifth step that is the earliest one, but I think also very interesting, possibly the most interesting that we've seen so far. So custom models for geospatial analytics, right? These would be generative models that are focused on spatial, GIS, spatial analysis, spatial data, what have you, anything under that umbrella. Like I said, we first really need to understand what these models are good for. So to do that, I just wanted to pull up this example from Hugging Face, right? This is just like an open portal for lots of different models, and there's lots of things under here. If you search Geo, there's two models that pop up. There's one that's really hasn't been used at all, and I think I don't know what it was exactly for, but and then the other one is the IBM NASA model, which we'll talk about in a minute. But if you think about GPT, it's trained on many billions of different pieces of text. This is a smaller model from Salesforce that's built on 7 billion reference points, right? 7 billion pieces of text effectively. And you can see they probably have some training data in here that you can see, but this is what they do, right? They generate text. So you give it a prompt, right? My name is Miriama, and my favorite, see what it comes back with. Oh, it's apparently too large to be here, but usually you can go in and type these and see what's going to happen. It might say, my favorite food is, pizza. And that's what it'll come back with. And that's really at the core of what it is. It takes some text and tries to figure out what else goes with it. Or you can ask a question, it might spit some text out. This is a smaller version of that, so it's very limited in terms of what it can kind of do. It's good for very specific things. Like it might be very good for data labeling or sentence completion or something like that, right? And you can, this is pretty cool because you can see like what are the most popular ones. This Falcon 180 billion points is, very, very large. I think there's, other ones that are a bit smaller that they have as well. So you have Falcon 7 billion, which you can do as well. So there's different components of like how much data these are trained on and if they're open or not. But that's basically what they do, is like you give it some text and it gives you some text back, right? There's lots of different things you can do there. And there's seems to, like, I've listened to some podcasts around this just to understand the bigger, ecosystem, as it were. I think the one I found the most helpful is Practical AI. If you're into a podcast, I definitely check that one out. But you can kind of see where these models go. I think there's hopefully some of them have this option to kind of type text in, but you can just see how many there are, right? There are lots of these coming out all the time, and they're just not stopping, right? But that's basically what they do, is you give it some text, you get some text out, and that's what ChatGPT does. It just happens to be trained on everything, just every piece of text that's been generated. So that's what they're good for, right? I think he did, just to start that. How does that concept apply to geospatial data? And it took me a while to kind of think about what that might look like. But we have two examples that are good, right? You can kind of see here. This is the first. The second component, I'm actually going to pull from some slides that I found via that podcast around, some of the, kind of, I guess, dangers or risks or things like that. But how you can improve it with human feedback, right? And this is from Aaron McCall-Staples and Nikolai Lyubimov. And they presented this at a different conference. I don't remember which one, but I found it. So you can kind of see how these LLMs are everywhere. People are freaking out. These models are much better with human signal, right? And I think this is super important because geography is very localized. If you remember the first rule of geography, closer things are more, associated than for things that are further away. Training a model on the globe, you can do, and we've seen people do that, but having some context to local issues is going to be important. And people are generally the best reference point for that. Now, a lot of this, you can see these AI tools is that, there's AI startups and they're really just calling out to GPT-3, which is a lot of people are doing because it's a really good model, right? So don't feel bad if this is like kind of what's happening right now. But it's not always bigger that's better. Some of these smaller models are really good. And then you get into these other issues, right? Because it's trained on everything. You could have bad data quality. There's bias built in, maybe social problems, or you can only apply these things to certain applications. And right now, these big text models, we've covered what they can do in the first, kind of 4 steps here. Beyond that, what do we do? And that's where these geospatial specific models come in. So I recommend taking a look at this presentation. They kind of talk about these components of, reinforcement learning and how you can do that, how that happens from a human input perspective, which you can kind of give it, is what does this look like for the outputs, output 1, output 2, and you kind of give it the a reward for the best models, and you kind of keep training it and filling that reward model back to give it what you think it should be. And this is the reward preference model. I'm not going to get in deep to this because it's sort of off topic, but I think just to very much keep it in mind, I think keep the human element can't be removed from these models to a certain degree. And as we start to get into this, I think that's going to be very important. Now, there's 2 models that I found that are very geospatial specific, and I'm just going to talk about those. The first is this IBM NASA model. And in effect, you can go into Hugging Face and see this here. They've pulled in the harmonized Landsat and Sentinel-2 data, and they used OpenAI, Open Science, and they're basically trying to create a labeling system for satellite imagery, which is, I think, very cool. Here's the demo, and this explains it better than I would be able to. So it's going to click on an area here. I think if I can just speed this up a little bit. So it has these pre-built kind of inference tasks, and it's generating them on demand, right? It's generating analysis that they understand from a global training perspective of lots and lots of data, where there's things like fire scars or where there's flood detection, and then changing that over dates, right? So you're not actually doing anything to tell the imagery what is and is not a flood impact or crops or these built areas or whatever this is. It just knows, because instead of generating it on AI, we're generating an analysis on imagery all the time, constantly doing that from a massive corpus of data, in this case, imagery, and what we tell it these things are. And some of that has to do with human inference, right? We know what some of these things are. We know where there's land use that's specific types or not. And this is, I just think, incredible. If you just take a minute to think about this, is it's a model that can be used from any time period, from any type of any imagery, to train on common things that we might want to understand. And the amount of work that might go into that from a geospatial analysis in the past is quite a bit, right? You might have to do a lot of different work just to get these things put out. But what they just did is they ran this model, got all this land use data back and then it is there. I think just think about that as conceptual, like it's taking out all these things that you can do and putting it into imagery. And I think that's kind of the promise of that first version. I think did I click out of there? I can find it here. And it does everything from floods, has the encoders, the spectral bands, and it just pushes this out. And this is an open model that you can start using, right? Just go ahead and start using it. You can run these things and do that. So I think this is interesting. It's I would go and check these out. I think we're just seeing, this is just recently released, but it's coming out, it's moving. I think this is very cool. The other one that I found, of course, this is on raster data, but there's custom models on top of your vector data as well. And this is the one I literally found this week that I think is very cool. It's from University of South Carolina, called sort of autonomous GIS, and you can read the paper here. But it kind of talks about how you can use an LLM geo, right? And this explained it the best to me is this image here, right? So you have a question: could you map the population living with hazardous wastes using these data sets, right? And this is a common question that you, as a analyst or whomever, whatever your role is starting with. You're trying to understand that here's a question, what do I want? Now the LLM goes out and figures out the input data, the operations you need, other intermediate data, and your final answer, right? And then that will perform the operations. And then that will push this back. So you can kind of see here, the LLM generates a solution graph indicating the data operations to answer the question, generates the code for each operation. So it takes the data and the model, and then it generates the code, and it generates the assembly into an executable program. So then it basically builds the the analysis for you from the data that you have that you're bringing in, and then it spits it out in a map and chart. So what does that look like? Is here's the question, right? You can see here's the census tract URL, here's the shapefile, here's the GDF. You join it to the tract population. You have a population map, population within the tracts. Here's the hazardous waste data set. And you can see this whole graph of how this solves it. It just from one text prompt, it built a whole workflow and then spits out a map like this and tells you here's the areas that are too close to this. And here's the code in Python written. I mean, to me, this is one of the coolest things I've come across so far. I mean, it's so new that I haven't had time to dive into it, but I was like, this is awesome to see how you can just take a question and put it into that. I was just shocked when I saw this. So kudos to this team. I'm definitely, I haven't shared this out to, kind of different channels yet, but I just think this is amazing. To be able to do something like that. This just brings this type of analysis and tools to so many more people. So I just see this as something that can continue to evolve. We're only scratching the surface right now. And that's sort of the cool message here, is that there's a lot of research and things going on. So that's kind of the talk I had for today. If there are some different questions that you might have, there's a Q&A tab here if you want to answer those. We will have a recording out for this if you have some sort of different questions or stuff like that. But if there are any questions, make sure to drop those in that Q&A tab below. I'm keeping an eye on it now. So all right, so kind of one question I think that generally pops up about all these different sort of problems and what these different tools are is risk, right? What's the risk of exposing your data to an LLM? What if it fails? What if it does those things like that? And I really tried to build out what I would generally think of as low risk to high risk, right? Bit by bit, you're leaving more and more of the operation to the AI compared to the human, right? And that's why I brought that last set of slides up that I think is something to definitely look at and dive into. There's a associating podcast with it, but how can you really get back to a place of using humans to augment or reward the system to provide the right examples? And I think that's probably something to keep in mind. Like I said, if writing code and having a human check it, you're pretty low risk there. If the code fails, you're not going to massively cause a problem. But if you're leaving the entire thing to AI and then sharing that back out as here's the ultimate source of truth, that becomes higher risk. Now, I think these models are going to become very, very good over time, but more and more you have to have some sort of element like that. And I don't know what that this is just happening now, so I don't know what the impact for sort of GIS analysts and the future is and anything like that. But it's just something to keep in mind, your mind on, and take a look at what that is. So I got another question. Looking at the impact of Geo AI. That's a really good question. I think there's a lot of terminology being generated right now, so it's hard to say what's generative AI, what's Geo AI. From my general, what I believe is a Geo AI is you're infusing those things with geospatial science, artificial intelligence, and up until now, before we really had Gen AI kind of expand to where it is, I personally believe that is really tied around these really complex sort of machine learning models or stuff like that. So a really common case is identifying things from imagery, which I kind of showed from the cars example, right? That required a lot of work to get up. Those models, the infrastructure, even the computing infrastructure takes a lot of work, right? And that's probably the thing that Gen AI is starting to break down, right? Is to say that no, you won't need all of this massive infrastructure potentially to support that, right? And as you train more and more models, they'll get better and better. So as you give more data, like you said, to, if you look at the NASA model, that's kind of like any imagery that's ever been put out there, those will continue to improve, right? And get better. And you can probably do more, very specific identification or feature identification. But like I said, I found 2 generative AI models that exist for geospatial today. So we're a ways off from that. It's not to say that there's these older, I don't want to say older, but I mean, we're talking about like 5 years ago old. These ways of doing things are not invalid as of today. In fact, they're very good for very specific things. If you're looking at, activity around ports or these very specific micro use cases, that's great. But you see with the Gen AI models, the NASA model, it's on very big things that you want to see, like floods or fire scars or these massive things. So I think we'll start to see, in the same way that many of the generative AI models are moving away from generalization into specific need, that will get there. A really interesting one, I think, is on using I'm really curious on how it happens with addressing, because addressing data is like a big problem, but it's all text-based. Of course, you have tools that have started to do this, like libpostal, but if there's a generative AI model for cleaning addresses, I think a lot of people would be interested in that. So, yeah, so another question from Linda: how will we know if the result is accurate? And where the source data does not have metadata very often. And that's very true, right? Understanding what's in the data, and speaking back to this whole concept of like prompt engineering, the more you provide the model, the better. But you're also providing it a certain sense of rigidity, right? You're telling it very specifically what you want to do. And that can control it in many ways. But if your problem is very general, that could be potentially, sort of a problem. The NASA model does this really well because it's providing a very general model of like big questions about what's happening on the globe, right? So I think it does a good job. That is where that human element remains very, 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 very important. And I think we just can't, over or underemphasize that. I should say underemphasize that, because, as you're looking at the results, especially from a local problem or something, a problem if you're an expert on, you can use this to speed things up. And I think that's a very safe way to address this right now, is you can speed some things up and automate some things. And, maybe that's data preparation or writing some queries, or, even, using a model to do something very repeatedly. But you still need a human element in there. I mean, yes, there's lots of text that's published around how to solve a specific problem. There's lots of writing on how to, study, the impact of, sort of Superfund sites and the aspects of communities or things like that. And just an example from the South Carolina model. But that being said, you have to assume that that data is really well curated and labeled. And if you think the census data, if you've ever dealt with the column headers there, you have to have the metadata to make that in any way useful. And how do those things relate? And what year and vintage of that data is there? So metadata is going to become more important. I think you're absolutely right with that. And how that plays into that will become clear. Now, I don't know what that looks like for a general model yet. Like if you just have generalized models out there, we've used the Gen AI to do data discovery, which I think is a very safe play. You're still adding a human element to say like, what is that data and is it applicable to me? It just helps me find it faster, which I think is still in that middle ground of safety. But on a bigger level, if you're turning this over to say, solve this, have a whole Gen AI model solve this spatial problem, then you're adding a certain level of risk. And as the sort of curator or user of that model, you have a very clear responsibility to have that data labeled correctly, understand the relationships, and program all those things together, because that's kind of the next label of this. But like I said, we're so on the beginning of that journey that I don't think anyone can answer that yet. I mean, there's people thinking about it, and I'm curious to hear all those ideas. But like I said, it's the very early days there. So, any other questions? If you want to drop those in. Those are the few I had for right now. Okay, so I think that looks like it for today. Once again, thank you everybody for joining. We'll have recordings of this up here shortly. And yeah, I find this is a very interesting topic. If you have any questions or want to talk more about it, you can reach out to me. Just can find me on LinkedIn and send me a message, or my email is matt@carto.com. Yeah, and hoping to learn more. So thank you again for joining today. Enjoy the rest of your week, and we'll see you around next time.